Good
Good
evening,
evening,
sir.
sir. Good evening. Yeah. So today we will start discussing about distillation. So this is somewhat vast topic. So we will try to finish this in this hour. Most probably we will discuss distillation, types of distillation, equipment used in it, and many other things. We will focus especially on fractional distillation, molecular distillation, and other methods. Okay. So can anybody say what is the purpose of distillation? Can anybody answer? The major purpose of distillation. So, in two terms, we can say distillation. One, it is a purification technique, and we can also say this is separation technique, right? So, most commonly, separation of ethanol and water mixtures are done using distillation. So, the basic principle in distillation, the word distill refers to the liquid mixture, and distillate or condensate is recovering liquid or condensed liquid. So, in distillation, basically, what we are doing, we are heating, we are boiling, we are evaporating the mixture of liquid, and you are condensing the vapors and collecting the vapors at different boiling points so that we can separate the liquid properly. So purification and separation technique అని చెప్పుకోవచ్చు. The two major steps involved in distillation is just now I said conversion of liquid into vapor phase by heating. Second one, recovering the vapors through condensing the liquid. So these two are the major important steps involved in distillation. So before understanding distillation, we need to understand certain important things. We'll move a little bit faster. You need to know Raoult's law. In order to learn the Raoult's law, you need to know lowering of vapor pressure. Generally, we call it LVP. Then you need to know relative lowering of vapor pressure, RLVP. Chemistry people know this very well. Then you should know about mole fraction. If you know these terms, then you will understand what is Raoult's law. Generally, vapor pressure exerted by the vapors of the liquid, any liquid is called vapor pressure. And this vapor pressure is not always constant. This vapor pressure changes by adding of impurities or due to addition of certain solutes. So in a solvent, in a pure solvent, the vapor pressure of a pure solvent, we can write it as a P naught, P0. This is the vapor pressure of a pure solvent. But lowering of vapor pressure is the vapor pressure of pure solvent minus, yes, chemistry people please, PO minus PS అంటాము. Yes, this is lowering of vapor pressure. So ఇక్కడ lowering of vapor pressure ఏమవుతుందంటే vapor pressure of a pure solvent minus vapor pressure of a solution. So generally vapor pressure tends to decrease. If you know, I don't know whether people working here in kitchen knows it or not. Generally చెప్తామండి పప్పు ఉడికే ముందు పప్పులో ఉప్పు వేస్తే పప్పు ఉడకదు. Do you know this? How many of you know? Your mom always shouts, "Pappu udikinaake uppestam," because when you add salt in it, lowering of vapor pressure jarigi, akkada proper boiling point raaka, your pappu will not boil. It will not cook properly. So that's the common kitchen science which we know. So PO minus PS is lowering of vapor pressure. Then what will be the formula for relative lowering of vapor pressure? PO minus PS by PO, right? So it is relative lowering of vapor pressure, right? So vapor pressure of pure solvent minus vapor pressure of a solution by vapor pressure of a pure solvent gives us relative lowering of vapor pressure. Sir, ఇదంతా కెమిస్ట్రీ మాకెందుకు చెప్తున్నారంటే just to make sure what is Raoult's law. Raoult's law speaks about RLVP directly proportional to mole fraction, right? So this is what Raoult's law speaks about. So what is mole fraction అండి? Yes, మొలారిటీలు మోల్ ఫ్రాక్షన్లు తెలుసు కదా? Number of moles of solute by number of moles of solute plus solvent. It's a mole fraction, right? So Raoult's law, in thermodynamics, we generally speak about Raoult's law. It states that the vapor pressure of an ideal solution. is dependent on vapor pressure of each chemical component and the mole fraction. So vapor pressure is directly proportional to the mole fraction, or relative lowering of vapor pressure is directly proportional to the mole fraction, is Raoult's law,
No,
right? So you should know this thing. You should know about all these binary liquids and all. ఎందుకంటే వీటి separation లోనే we are going to use our distillation techniques, right? So నేను చెప్పినవన్నీ ఇక్కడ ఉంది already. No need to go in these details of mole fraction and all those things because you already studied this in intermediate level. So just understanding of what is LVP, RLVP, and mole fraction and relative lowering of vapor pressure సరిపోతుంది. అసలు ఐడియల్ సొల్యూషన్ అంటే ఏంటి? What is ideal solution? What is non-ideal solution? A solution which obeys Raoult's law in all conditions is an ideal solution. Generally, ideal solutions doesn't exist. Mixtures of certain solutions, we call it them as an ideal solution. And those solutions which does not obey Raoult's law are called real solutions or non-ideal solution. So that thing you should know. Okay, so there are a lot of examples of non-ideal solutions like benzene and ethanol, chloroform and chlorohexene, carbon tetrachloride and acetone. These examples you should know. They might ask in exams. So see, I'm stressing on only those things which might be asked in exam. A mic ఎవరు ఆఫ్ చేయాలండి ప్లీజ్. చాలా డిస్టర్బెన్స్ వస్తుంది. Yeah. So yes, please note it down. Examples of non-ideal solutions: carbon tetrachloride and acetone, chloroform and cyclohexene, benzene and ethanol. Okay. So the important thing we'll also discuss about azeotropic mixtures. Can anyone give me like explanation or like small hint on what are azeotropic mixtures? How to separate them in azeotropic distillation? Okay, we will discuss it. Then, before going into those details, let's see about the application of distillation. And like we discussed, separation of volatile oils. So we are going to use distillation techniques. Purification of drugs obtained by the chemical process, we are going to use purification distillation technique. And purification of organic solvents, we are going to use distillation technique. Manufacturing of official preparations, we are going to use distillation techniques. Separation of drugs obtained from plant and animal sources, we are going to use distillation techniques. Refining the petroleum product, fractional distillation, ఇక్కడ distillation is used. Quality control methods check చేసేటప్పుడు we'll go for the distillation. And recovery of solvents portion will go for distillation. So these are the applications of distillation. Please note it down. What are the different applications of distillations? Make it fast. Separation of volatile oils, purification of drugs, purification of organic solvents, manufacturing of official preparations, separation of drugs obtained from plants and animal source, refining of petroleum products, quality control methods, and recovery of solvents. These are the applications of different distillation procedures. Hope you have noted it. Now, let's jump into different distillation techniques. See, I'm moving a little bit faster because I know we are in just second unit. We need to rush. We have lot of other important things to be discussed. So, what different distillation techniques we are going to study in this class? Simple distillation, steam distillation, distillation under reduced pressure or flash distillation, fractional distillation or also called as rectification. Then we are going to discuss about distillation under reduced pressure. Then we are going to discuss about steam, already we discussed, azeotropic distillation, and molecular distillation. So these are all different distillation techniques and equipments which we are going to అండర్స్టాండ్ టుడే వీటన్నిటిలో అన్నిటికంటే ఇంపార్టెంట్ నన్ను అడిగితే రెండే అండి ఒకటి మాలిక్యులర్ డిస్టిలేషన్ another one is fractional distillation and in every distillation equipment we need to know what kind of material we are using and what are the merits and demerits of that particular type of distillation technique. So steam distillation, simple distillation, distillation under reduced pressure, fractional distillation, and molecular distillation. These are the different distillations which we are going to discuss to today's class. Okay, let's start with the simple distillation. Simple distillation is very easy and the construction. What we have a simple still receiver condenser. That's it. You can see this is the simple distillation construction. Very simple. You can clearly see here there is a still in the still the liquid to be distilled is poured and there is a receiver in which we are receiving the condensed product. Like we discussed, there are two steps. Step one is evaporation, step two is condensation. So evaporation is taking place here and condensation is taking place here. So that's the basic thing what you need to understand. So the important part, very important part of distillation is condenser, because this is that part which is helping these vapors, hot vapors, to condense and simply fall down back into this still, or you can say receiver, right? So let's see principle involved in simple distillation. Simple distillation is carried out at the boiling point of the liquid, which boils when the vapor pressure is equal to atmospheric pressure. ఈ point చాలా important అండి. When does liquid boil? Liquid boils at their boiling point కాదు. It generally this was being discussed by the small children. When does liquid boil? Liquid boils, liquid evaporates when its vapor pressure crosses atmospheric vapor pressure. అప్పుడే vaporize అవ్వగలుగుతుంది. For example, if we see there are certain liquids which are volatile. Now answer me why petrol is volatile and water is not volatile? Don't say its boiling point is less and boiling point is more. Water's boiling point is 100 degrees, but petrol is less. That's why it's evaporating at room temperature and anakandi. The major reason, keep all these things in the mind and say why water. Sir, parent is calling. Please talk to him. Say I am in class. So why water? Why water is not evaporating at room temperature, whereas petrol is evaporating? Come on, fast. If you don't know answer, just say don't know. I'll explain you. But don't waste my time, please. Yes, nobody knows it. Any guesses? So Krishna Garu, Swati, Srikar, Afrin, Rajamani.
Don't know, sir.
Yeah, very good. Mannan, any guess? Yeah, the major reason and the water when it is at room temperature, water's vapor pressure is less than atmospheric pressure. So water cannot escape into atmosphere, water cannot evaporate into atmosphere. It is water vapor pressure, it is atmospheric vapor pressure. Atmospheric pressure. If ATM, atmospheric pressure is more than any liquid's vapor pressure, that liquid cannot escape, that liquid cannot evaporate. But the liquid petrol or like any volatile oil, when they are at room temperature, their vapor pressure is greater than atmospheric pressure. That's why they started evaporating at room temperature itself. You can say the petrol is volatile, the diesel is volatile when compared to water because their vapor's pressure is more than atmospheric pressure. Then the question is, sir, why water is boiling at 100 degrees? Because when you are giving the temperature, it's giving the kinetic energy. Like according to collision theory, water molecules are colliding with each other. They are gaining the kinetic energy and they are getting the energy, and the vapor's pressure is increasing. And vapor pressure, when it touches to atmospheric pressure, then water starts boiling. Not only water, any liquid's vapor pressure, when it becomes equal to atmospheric pressure, water boils. When it crosses it, then water evaporates. You can know this by example. You should know that our soldiers who are fighting at Siachen, 30,000 like feet height low, Akkada, they can't cook the food. Why? Because at that point, the atmospheric pressure is too high and water boil avvadanti easyga and you can't cook food at that temperature. So there they need to use pressure cookers in order to build the extra pressure to cook the food. Akkada, you can't simply cook the food without cooker because just boiling water cannot boil your aloo, cannot boil the rice, and cannot cook the food because of elevated in atmospheric pressure. Got it? So వాళ్ళకి చాలా కష్టాలు ఉండడానికి వన్ ఆఫ్ ద మేజర్ కారణం ఈస్ హై అట్మాస్ఫిరిక్ ప్రెషర్. సీ లెవెల్ పెరుగుకుంటూ పోతే అట్మాస్ఫిరిక్ ప్రెషర్ ఇంక్రీజ్ అవుతూ వెళ్తుందండి. పీపుల్ హూ ట్రావెల్డ్ ఇన్ ఏరోప్లేన్స్ దే నో ద అట్మాస్ఫిరిక్ ప్రెషర్ ఎట్ దోస్ heights are too much. So they will maintain other positive pressure in the plane. కిటికీలు ఎందుకు తెరుచుకోవు? కిటికీలు తెరిస్తే అంతే ఇక గోవిందా అయిపోతాం మనం. ప్రెషర్ డిఫరెన్స్ వచ్చేస్తుంది, చచ్చిపోతాం, ఆక్సిజన్ లెవెల్ సరిపోవు. Right? So you should know these basic things, right? So this is the basic principle involved in simple distillation. The mixture undergoes better separation by distillation if the relative volatility is high. The liquid is boiled by supplying sufficient heat. So this is simple distillation. Nothing to be remembered in simple distillation. Just we need to focus on advantages and limitations because it's so simple to see. Coming to uses of the simple distillation, very important use in pharmaceuticals. Very important use in pharmaceuticals is we use simple distillation in preparation of water for injection, WFI. Water for injection is used in preparation of parenterals, small and large volume parenterals. It's very important compared to other waters because this is pyrogen-free liquid. This is sterile, bacteriostatic, pyrogen-free liquid, and this is used as a diluent in small and large volume parenterals. So, water for injection కోసం simple distillation is an important procedure. Next, it's used in preparation of volatile and aromatic solvents. It's used in purification of organic solvents. It is used in preparation of spirits, of nucleus, either and aromatic spirits of ammonia also. And it is used in separating non-volatile solids from volatile solids. And the separation of liquids, volatile and non-volatile liquids, preparation of water for injection, preparation of aromatic solvents, preparation of aromatic spirits, right? Preparation of ammonia, aromatic spirit of ammonia. We are going to use simple distillation. Coming to
Sir, one
demerits.
doubt, sir.
Yes, please.
వాటర్ ఫర్ ఇంజెక్షన్ అంటే ఇప్పుడు మనం ఐవి కానీ ఐఎం కానీ సాలిడ్ డ్రగ్స్ వాటిని డిజాల్వ్ చేయడానికి వాడుతారా సార్?
ఎస్ అండి. వాటర్ ఫర్ ఇంజెక్షన్ జనరల్ గా మీ ఐడియా కోసం అండి, చిన్న పిల్లలకి వెన్ వి టేక్ రీకాన్స్టిట్యూటబుల్ సిరప్స్, డ్రై సిరప్స్, దాంతో పాటు రెండు చిన్న ఆంప్యూల్స్ ఇస్తారు. We will use those ampoules, open them and add that in the syrup bottle and shake. Those ampoules మీద చూడండి, it is written water for injection. The instructions will be given either use warmed and cool water or use this water for injection ampoules. ఇంకా parenteral preparation అప్పుడు, injections preparation అప్పుడు we don't use normal water because there is chances of presence of pyrogens in normal water. So we use water for injection. We will prepare water for injection. How we will prepare water for injection? We will discuss that in the parenterals. To prepare water for injection, we should go for filtration through bacterial proof filters, membrane filters, and distillation, so that we can remove all the possible pathogens, even the pyrogens and particulate matter. Okay, Andy?
Okay, sir. Thank you.
Yeah. Then coming to limits, it works with relatively pure liquids, and degree of separation achieved is lesser than fractional distillation. So more efficiency is seen in fractional distillation, and higher boiling point difference can only be distillated if there are two liquids in which the difference between their boiling point is higher. Then only simple distillation possible. If not, it's not useful. So steam simple distillation lo unna chala limitations valla we are going to discuss next type of distillations, right? So next is fractional distillation. This is very 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 important. The major difference బొమ్మను చూసి మీరు చెప్పండి నాకు ఏంటి తేడానో నార్మల్ డిస్టిలేషన్ కి ఫ్రాక్షనల్ డిస్టిలేషన్ కి. ఫ్రాక్షనేటింగ్ కాలమ్ ఇది మేజర్ డిఫరెన్స్. The difference between normal distillation, normal distillations, and fractional distillation is we are going to have fractionating column. See, I highlighted it. The fractionating column lo different stages untai. So here the major fractional distillation takes place. How it's going to take place? Enrichment of vapors. గుర్తుపెట్టుకోవాలి. చాలా సింపుల్ గా చెప్పి పడేస్తాను ఫ్రాక్షనల్ డిస్టిలేషన్ అర్థం చేసుకోండి. Enrichment of vapors. What is happening in enrichment of vapors? For example, in this liquid, there is a mixture of two liquids and they started evaporating. So now these vapors, when they are going up, they will touch this fractionating column, condense and start falling down. Condensed liquid. Let's imagine in this condensate you have 10% of a solution A. Now this condensate comes or counteract with the vapors coming up, traveling up. Now this vapors also have 10% of solution A or mixture A. When these vapors are going up, when they react with these condensate, these vapors get enriched and these vapors will become 20%. Now this 20% vapors goes up, touches the point and start condensing back. Malli ippudu kinda condensate వచ్చే దాంట్లో I have 20% of my mixture A. Now again vapors are coming up which contain 10% of the pure solvent vapor A. Again when they come against each other, these vapors are enriched with the 20%, then it will become 30%. Allah, when go on slowga, we will get 99% pure mixture A. That's how enrichment is occurring. You will see in detail so that you can understand. మీకు ముందే అర్థం కావాలని I try to explain in this way so that you can understand. Counteracting of an upward moving vapors and downward moving condensate takes place, and this is going to enrich the vapors. Vapor enrichment is going to improve the condensate quality. See, ఇక్కడ చూపెడుతున్నాడు నేను ఇప్పుడు చెప్పిందే. You can see all these stages to what's happening. Liquid containing 10 అన్నాడు 20 అంటున్నాడు 20% it's going up. Condensate vapor containing 60% is coming down. When those counteract with each other, 60 plus 20 ఏమైపోయిందండి 90 అయిపోయింది. So simply while coming up my vapor became enriched from 20% to 90% just because of what? Counteracting with the condensating liquid. Adi work of fractionating column. అర్థమైందా అండి? See, we will see in detail, then you will understand. A technique used for separation of two or more miscible volatile liquids. A technique used to separate two or more miscible liquids whose boiling points are too close via fractionating columns is important. Fractionating columns is termed as fractional distillation. The process involves heating the mixture and partially condensation of the vapors along with fractionating column, which then returns as liquid. Thus, the process is also called as rectification. ఎందుకంటే మిస్టేక్ రెక్టిఫై చేసుకుంటున్నాం. ఏంటిది నా మిస్టేక్? నా కండెన్సేట్ తో 20% ప్రోడక్ట్ ఉంది. ఆ మిస్టేక్ ఎలా రెక్టిఫై చేసుకుంటున్నా? మళ్ళీ పేపర్ ఎన్రిచ్ చేసుకుంటున్నా. మళ్ళీ కిందకి వెళ్ళాక మళ్ళీ ఐఎమ్ కంటిన్యూస్లీ రెక్టిఫైయింగ్ దిస్. సో రెక్టిఫికేషన్ అంటున్నాం. రెక్టిఫైడ్ స్పిరిట్ అంటాం alcohol ni, because alcohol purification lo kuda we are going to use fractional distillation procedure, right? అది కూడా చెప్పుకుంటాం. మనకు స్పిరిట్స్ టాపిక్ ఉంది, క్యాలిక్యులేషన్స్ వస్తాయి, అలిగేషన్ మెథడ్, ప్రూఫ్ స్పిరిట్ అండ్ ఆల్ దోస్ థింగ్స్, దెన్ వి విల్ డిస్కస్
స్పిరిట్.
యా. సో రెక్టిఫైయింగ్ వర్డ్ ఇక్కడ నుంచి వచ్చింది. Okay, so let's see the principle. Very simple. The process of fractional distillation involves ఇప్పుడు చెప్పాను counter current diffusion. Counter current between what? Counter current between the condensate coming down and between the vapors moving up. Vapors moving up, condensate moving down. So our counter current is important as components each at each equilibrium state. When the liquid mixture is distilled, the vapor is allowed to pass through the fractionating column to undergo partial condensation. Within the column, the vapor raises up from the still, comes in contact with the condensation vapor, returning to the still. చెప్పాను ఇందాక. As a result, vapor becomes rich with the volatile content. So enrichment of vapors is taking place because of counter current mechanism. The vapor is allowed to condense and the liquid is heated repeatedly to that equilibrium is achieved between the both the phases. In the both phases, the liquid phase and vapor phase at each stage. This leads to separation of component of the mixture. Now got it? మనం చెప్పుకుందే ఉందా లేదా? Right?
Yes, sir.
Yeah. కన్స్ట్రక్షన్ లో సో సింపుల్ అండి. ఫ్రాక్షనేటింగ్ కాలం ఒక్కటి యాడ్ అవుతుంది అలాంగ్ విత్ ద స్టిల్. కండెన్సేట్ రిసీవర్ ఉంటుంది, స్టిల్ ఉంటుంది, కంప్రెసింగ్ ఫ్రాక్షనేటింగ్ కాలం ఉంటుంది, దాని తర్వాత కండెన్సర్ ఉంటుంది. సో ఇది ఒక్కటే ఎక్స్ట్రా కన్స్ట్రక్షన్ లో. కెన్ సి ద ఫ్రాక్షనల్ డిస్టిలేషన్ apparatus is shown like as shown in the figure. The fractionating column is the apparatus for the large scale operation is introduced between the still and condenser. Steam coil is used for supplying heat at the bottom of the column and the condenser is equipped at the column top. The column provides sufficient flow of conditions flow into large areas. The contacting devices are represented by broken lines across the column. So ఈ column లో broken lines మనకు చూపెడుతున్నారు ఇది distillating column అని. Okay, so this is about the fractional distillation. ఇప్పుడు 20, 30, 60% చెప్పుకున్నామా, దాన్నే మళ్ళీ ఎక్స్ప్లెయిన్ చేస్తున్నాడు విత్ ఎగ్జాంపుల్. వర్కింగ్ చూద్దాం. దిస్ ఇస్ అ మిక్చర్ ఆఫ్ టూ కాంపౌండ్, మిక్చర్ ఏ అండ్ మిక్చర్ బి అనుకుందామండి. మిక్చర్ ఏ ఈజ్ 20%, mixture B is 80% అనుకుందాం. In this process, liquid mixture to be distilled is introduced into the boiler and still heated by means of steam. Let us assume a mixture of two miscible liquids A and B. Since the boiling point of liquid A is more volatile, liquid A is less than the liquid B. So liquid A is more volatile when compared to liquid B. In this scenario, these liquids do not produce a constant boiling point mixture. So ఇప్పుడు ఏమైతుందో చూడండి వర్కింగ్ లో. When the mixture reaches its boiling point, the vapor composition curve shown by the lowest pair of the curves are drawn, indicating that the vapor containing 60% of A. ఇక్కడ vapor containing 60% of A in the curve. Right? Now, when the vapor condenses, the resulting liquid is again heated to the boiling point. This condition is represented by the second pair of curve from the bottom indicating the vapor containing 90% liquid. This one, right? So now this vapor impinges on a cool surface and gets condensed. This fraction is re-vaporized by heating it to its boiling point. This condition is represented by the third pair. The third pair of the curve from the bottom indicating the vapor containing 90% of A. This fraction of vapor impinges on cooling surface and this condition is represented by fourth pair of curve. This vapor contains more than 98% of the vapors. The vapor moves to the condenser at the top of the column and gets condensed. Student table clear, you will understand. There are two mixtures, liquid A and liquid B. Liquid A is more volatile, liquid B is less volatile. Now vaporization starts. Starting initially vapors and 20% only. Then when they counteract with the condensate 20 plus 60, it became 90. When again it contracts with the condensate, they became 98. సో కంటిన్యూస్ గా కండెన్స్ అయ్యి కింద పడి రీబాయిల్ అయ్యి మళ్ళీ ఆపరేట్ అవ్వకుంటూ వెళ్తుంది. సో కంటిన్యూస్ గా మనకి స్టిల్ లో ప్రోడక్ట్ ఇస్ బికమింగ్ కాన్సన్ట్రేటెడ్, more and more concentrated. That's the basic thing you should remember. Okay, so these are the curves you can understand, you can see them. Next uses of the process of fractional distillation is used for separation of miscible liquids. Example, acetone and water, chloroform and benzene. So when the liquids are miscible and when you want to separate them, we are going to use fractional distillation. So this is about the fractional distillation and fractionating column. You should know this with an example so that you can understand it. Okay. Next, after fractional distillation, we are going to discuss about in the steam distillation. Yeah, steam distillation. Simple distillation key, steam distillation key, you can see the difference here. In fractional distillation, we have fractionating column, but in steam distillation, we are having two heating sources. One heating source, we are heating the distillate here still. Second heating source, we are also sending the steam inside the still. Why there is a need to send the steam? Adi chudal important. Okay, so in a mixture of immiscible liquids, boiling occurs when some of their vapor pressures and atmospheric pressure becomes same. In that point. For example, in a binary mixture of water and turpentine oil, turpentine boils below the boiling point of pure water, but turpentine boils at much higher temperature than that of the water. So the principle behind steam distillation is similar to that of fractional distillation in case of volatile substances miscible with the liquid. So steam distillation, so what we are going to do, we are going to send extra steam into it. Why we are going to do this? For example, in certain binary mixture, if the boiling point of the two liquids low, if a lot of variation is there, and when they are mixed together, then their boiling point increases. So in order to achieve that higher boiling point, we are not only heating the still but also supplying the steam. So the steam distillation apparatus are as shown in the figure. ఇలా ఉంటుందండి ఎక్స్ట్రా స్టీమ్ కోసం రెడీగా ఒక ఇది ఉంటుంది which yeah, so as shown in the figure you can see, so a bent tube is there which is supplying the steam into the still. If the pressure within the steam generator rises, water will be forced out. This tube is used to release the pressure in, right, indicating the steam can be almost empty. So a bent tube is passed to the another hole on the other end of the tube and is attached to the flask to a rubber bug and reaches the bottom of the flask. So the flask contains non-aqueous liquids, like example, crude containing volatile oil. So generally the delivery tube is inserted through the another hole of the rubber bug into the flask and the condenser with an adapter. So the condenser is called a receiver flux. So this is how the construction is there. Let's see the working, simple working only. The flask is filled with non-aqueous liquid. Subsequently, small amount of water is added to it. Then water is filled in the steam can. Both the flask and the steam can are heated together simultaneously. Then the mixture heats up and the steam carries the volatile oil into the condenser, where the oil gets cooled by the cool water and it is condensing back. So the condensed immiscible liquid is collected in the receiver. Distillation process continues till non-aqueous liquid distill off completely. Water and organic liquids collected in the receiver as two distinct layers, which are separated using separation flasks. So this is what happening in steam distillation. So one important thing to be remembered in steam distillation is we are going to use excess steam in order to increase the boiling point, in order to give the efficient distillation in non-aqueous liquids. So if you see the merits and demerits, then you will understand and the user generally steam distillation is used for separation of immiscible liquids, whereas fractional distillation is used for miscible
Miscible
liquids.
liquid.
Yeah, volatile oils like clove oil,
Nice.
anise oil, eucalyptus oil can be extracted using this process because they are immiscible in water. So it is used for purifying high boiling point substances. మనం ఫస్ట్ చెప్పుకున్న purification technique కూడా అని. Like essential oil of almond oil purification లో we are using steam distillation. It is employed for distillation of camphor and it is also used in preparation of aromatic water.
Aromatic water.
Aromatic water లో ఇప్పటికీ రెండు చెప్పుకున్నాం, నార్మల్ డిస్టిలేషన్, స్టీమ్ డిస్టిలేషన్. అలా కంపారిజన్ కూడా గుర్తుపెట్టుకోవాలి. So the only demerit is it is not employed in conditions where the immiscible liquid is reacted with water. ఇది మెయిన్ demerit. Now very important, molecular distillation. Molecular distillation లో ఏం జరుగుతుందంటే the distance between still and condenser is very less. You can see here, very less. ఎంత లెస్ ఉంటుంది అంటే it should be equal to the free mean path. Please note down, very important, short path or free mean path we call it, the path that can be traveled by a molecule without colliding to any other molecule is called free mean path or mean free path. This is the only main point in molecular distillation. Molecular distillation, also known as evaporative distillation or short path distillation. ఎందుకు షార్ట్ పాత్ అండి? బికాస్ ద డిస్టెన్స్ బిట్వీన్ ద ఎవాపరేటర్ అండ్ కండెన్సర్ ఆర్ టూ క్లోజ్. ఎంత క్లోజ్ అంటే ఫ్రీమింగ్ పాత్. ఇట్లా వేపర్ అవ్వంగానే కండెన్స్ అయిపోవాలి విత్ ఇన్ సెకండ్స్, అండ్ ఇట్స్ టూ క్లోజ్. ఇట్ డిపెండ్స్ ఆన్ ద ప్రిన్సిపల్ ఆఫ్ సింపుల్ డిస్టిలేషన్ విత్ సమ్ మోడిఫికేషన్. It is defined as distillation process in which each molecule in the vapor phase travels free mean path and gets condensed individually without any intermolecular collision on application of vacuum. So simple distillation lo two modifications. One, you're applying vacuum. Other thing is you're allowing the molecule to only travel short distance of free mean path. Got it? See, I'm explaining it again. Molecular distillation ఎందుకు అంటున్నామంటే molecular level లో distillation అవుతుంది, and ఇక్కడ we are allowing the particle vapor phase to travel the free mean path. అంటే it's a distance traveled by a molecule after evaporation without colliding with an other molecule. దాన్ని ఫ్రీ మీన్ పాత్ అంటాం. ఇప్పుడు అక్కడ ఎవరన్నా శ్రీకర్ కూర్చొని ఉన్నాడు, శ్రీకర్ ఫ్రీ మీన్ పాత్ ఎంత అంటే శ్రీకర్ దేన్ని టచ్ కాకుండా ఎంత దూరం నడవగలడు? లేవగానే బెంచ్ తగులుతుంది, కుర్చీ తగులుతుంది, గోడ తగులుతుంది. ఎంత డిస్టెన్స్? 1 మీటర్, 1 ఫీట్, 1 సెంటీమీటర్, 1 ఇంచ్. దట్ ఈస్ హిస్ ఫ్రీ మీన్ పాత్. అలా ఎవ్రీ మాలిక్యూల్ హ్యాస్ ఇట్స్ ఫ్రీ మీన్ పాత్. సో ఆ ఫ్రీ మీన్ పాత్ కంటే తక్కువ డిస్టెన్స్ లో కండెన్స్ చేస్తాము. సో వై వి విల్ డూ దిస్? మెనీ సబ్స్టాన్సెస్ సచ్ యాజ్ విస్కస్